the technology works. Does the technology work? Twitch says it does. All right. Today is the 16th of April here at ASU. We're at CSE598, software exploitation. And we're on this endless trek of trying to make Windows work on the dojo. I kind of died last week trying to make that happen. That was my bad. I am not the best when it comes to time management. And so in turn, I obsess and I push myself too hard and died, which is why we didn't have class last week. But we're here today. So what's going on? These may have been memes from long ago, but they were Windows memes. So the first one, I know this is someone who's not in the class themselves, but it's a decent meme. We changed up the Windows infra. Do not try and read the stuff that is in Y, don't run Y challenge. C challenge is what you want to look at. And C flag is flag that you don't want either. Like there's a lot of bait things. I think I didn't even look if find out if the instructions are valid now. Yes, okay. The updated instructions are there. So I try and explain what is the correct thing to interface with. But this little blob of text is like hyper important. If you just look at it, you're like, oh yeah, I can just cat the flag. You're in for a bad time. There's lots of ways that you can fail in unexpected manner. The only thing that I have here for the kind of current module that we're doing is a little blurb about Rob Defender, which up until earlier today, there was only one challenge that utilized that. As of right now, for silly reasons, you can see all of these, despite the fact that my screen here says hidden. So originally there was one challenge that utilized Rob Defender. There are now, I think, another 6, if I remember right. And so that will become increasingly a thorn in your side. The goal of these Rob Defender challenges is not to understand Rob Defender. Rob Defender is written in C++, which is more pain to reverse engineer if you try than what you've seen thus far. C++ has its own fun stuff to it. But also there aren't intentional vulnerabilities in Rob Defender to begin with. So I wouldn't spend time looking there. The goal is always to look at what is running in the challenge. And the challenge is, in most of these, a calculator. So there's lots of traps. One of the things that I'm going to probably fix later tonight, when you are doing these challenges, particularly the new ones that were added, this ties into the concepts in the original prior module or prior modules lecture videos, where we talk about how kernel 32 goes to kernel base, which goes to NTDLL. At the end of this, and I'll try and demo it here as well, we'll see how that flow of kernel 32 all the way into NTDLL circles all the way back to that ridiculous rant I had about everything being an object in Windows, because you'll actually get to see some of that if I succeed at my intended demo today, where we'll see that in source. Not that, but documentation is hard, and you spend a lot of time typing MSDN followed by another word. I think I've become the person with 1,000 Chrome tabs, right? As I've worked on this stuff. Rob Defender is, at this point, several thousand lines of C++. It's grown massively out of proportion. Is there any document that you've read? I've had to read probably 3 or 4 more, like 3 or 4x more in order to try and make all this work. So your pain, I understand. Since we only had one Rob Defender challenge, and this will probably, unfortunately, be true for the later ones as well, because I may have missed something in the documentation in my grand quest to understand everything that could happen on Windows. Rob Defender will hook certain functions, right? So I believe the first two levels are messing around with virtual allocating virtual memory. And it turns out that for almost anything that you do on Windows Win32, there's not one function that like performs this action. There's not two. There's not three. In some cases, there's like 10. All right. The goal of these challenges, just to be clear, the first one, alloc for what one that doesn't have the one is meant to be trivially solvable by just kind of looking at some docs and being like, hey, there might be another function. But if I were to start up the follow-up of it, just so that people are experiencing pain in the correct place. While Rob Defender is not the focus of the module, this rd rules.txt is intended to give you some insight into like what is this messing around with. Some of these numbers may or may not mean anything, right? That's just the beauty of me getting stuff live. So with this one here, we see that I'm blocking or hooking in some way on virtual alloc X, virtual protect to from app, virtual protect to, virtual protect EX, and virtual protect. All of these have to do with like a common theme here. What am I trying to stop you from doing? Okay. It is worth pointing out that for many of these hooks, it is not just if you call this, I'm going to exit. All right. It is probably not clear from the rules themselves, but the challenge description says some virtual allocations are suspect. Right now, the rules format, the way this is all consumed, doesn't convey this clearly in the rule. But I guarantee you that not every virtual protect is going to result in ROM Defender killing. Okay? And so this is something that you'll have to kind of figure out and play around with. The goal is not for there to be like, oh, there is virtual protect 3 app plus X, right? Hiding somewhere in the documentation. That is not the goal. The goal is not to have you do this like Easter egg hunt in documentation to find some hidden gem. So if that's what you're thinking you need to do, you can spend time doing it, and there might be something, but that is not my intention. All right. So in this case, the goal is specifically, I'll tell you what it's supposed to be doing. Just point blank. Does anyone know? Anyone have a chance to look at it by chance? The challenge?
I just looked at the rules.
What did the one before do?
Well, from reading the rules to stop virtual alloc and virtual alloc X and virtual protect.
Did it stop all of them?
No, it just stopped a subset.
Okay. Do you know what the subset was?
Just the first, the biggest two I would think of, virtual alloc and virtual alloc X. I think
so. Those are the functions, right? And I'm hooked on them. But there's like this kind of give and take that I have to do with these functions, which I get to learn the hard way as things blow up in horrendous, scary ways. Is it reasonable for me to destroy every program that mallocs anything?
No, then the system won't work.
Right. I know I obviously have carved out some exceptions that are also not intended to be your escape path here. But you can, I can do it. You can write something. Let's make sure. Move. Do I have a do.c? There's always a do.c.
It'll be in the Windows VM.
Do I?
You're gonna run something for me.
You know, this wasn't my intention. We're just kind of free going here. I'll circle back to that. All right. There's only like 4 slides. Let's make it all the way through. So ROM Defender is not the brightest thing, right? And that is also by design. These are meant to be a thorn in your side, but not a ridiculous thorn in your side. And you can reason about what's going on without having to reverse engineer ROM Defender. Because how do these hooks work? I showed it 2 weeks ago. So a long time ago, right?
If I remember right, they hook onto the function name and change the actual, like, where the function will go to. So the actual body of the main function goes to a different function that you have created that actually
So it
shares the name, something along those.
Something along those lines. It rewrites the prologue.
Yeah.
Right. So when I have, what did this thing do? Virtual Alec. Right. None of these were controlled. Right. I'm doing something with all of these functions, except for the last one. But hopefully that's kind of obvious that that's a troll. There's not a function called that. What's happening here is where virtual Alec is in memory. The beginning of that function, or where that symbol resolved to, is now going to jump you to some other region of memory. But that region of memory has to be in the process, doesn't it? If I'm jumping execution to somewhere in your running process, or in this calculator, or in whatever, it is somewhere in there, right? And so that means that if I were to debug this, right, I could see where in this hook I'm going. Which means that logic is visible if you go down the rabbit hole. Schedule, logistical things, Windows. So whatever, there's some new stuff. It's live. I plan on trying to drip out a couple more over the next couple days. I'm giving up on due dates. I'm giving up on any rhyme or reason. It's not fair to you. It's not fair to anyone. So I'm just going to make everything that we do going forward do at the end of the semester. Just makes it easier. That includes checkpoints, the whole shebang. Right. I got a post grades on the 12th, so that means the 11th is when everything will be post grades due. Is that fair? Right. Kernel. I was hoping we'd get time to touch kernel. That didn't happen. As far as like improving the challenges, that means that it will be pain, because like the addition was to make the ramp nicer. I'm gonna list it on the course dojo Friday. Again, it'll be due at the end of the semester. I plan on talking about kernel for the next 2 weeks after this. So this will be the last day we talk about Windows stuff. There's no changes planned, but maybe there's a surge of productivity, and one can hope. Demo plans. There's a brief aside on nothing. That is how far I got on this slide deck. Right? When somebody says they have one question, just say no. All right? It's a trap. Okay. So let's reason about what's going on here on this challenge, where we saw there is the virtual Alec hook. We can have our do.c here. We'll include windows.h. We'll have some main function. Now, I think both of you guys solved Alec for what or whatever, what the Alec. Did you use C or did you use assembly?
I used a mix of both.
You used a mix of both. Okay.
Well, it wasn't pure C or pure assembly. So.
Okay. The reason that I asked, the intended here, when I wrote this, the solution for this, it is all C++. It doesn't mean that that's the case for all of these, but as this becomes increasingly complicated, if you try and do it all in assembly, you're going to have a very bad time. Because it's going to be a ridiculous amount of assembly. And as you've already seen, the arguments to functions become huge on Windows, right? And you haven't even gotten to the real deep stuff yet. But
functions in 20 parameters.
So this is all how to open a file, right? I think it's not a secret. We could roughly imagine that what kind of things am I going to be hooking on here? Create file A. Maybe I mess around with stuff that's in kernel base. Maybe I go down to NTDLL, right? Let's see. That's a lot of arguments. It's not quite 20, right? But that's a lot. And what you'll notice here is these start becoming very weird objects. These are no longer like strings. These are no longer like what is a p object attributes, right? I don't know. In trying to build a p object attributes in assembly is probably not what you want to do, right? And so we need to start thinking in a higher level language, and you'll find that this is both the common case when you're talking about Windows exploitation, but also a borderline necessity. Maybe cat RD rules. Okay, so let's just have a nice little function here. It's going to say a nice little program. It's going to say puts hello. We're going to say puts goodbye, because all I want to know is like, did we manage to execute, right? How far did we get? And then I want to call virtual alloc. Anyone by chance remember? I wouldn't expect you to. All right. Optional address. Optional means it can be null. Give me a size. I want a page. Allocation type. Anyone remember this one? Mem reserve. Yep. Ord with mem commit. And then we have to choose the protection. Now, out of the potential things here that you see, what do you think I could care about as an EDU? Do I care about how big an allocation is? Is that a reasonable thing for me to like filter and stop you? Yeah, I could, but like if we're talking about like generic programs, there's an arbitrary program, they may have a reason it needs to allocate a page or 20 pages or 8 bytes. I can't say whether that's malicious or not. Am I going to be stopping people from running the two arguments here that make memory actually work? No, I'm probably not going to be doing that. So the thing that I probably am looking at from is this a malicious program, is what are you mapping, right? Am I mapping, well, what would be, or type of memory mapping protections that would be like kind of suspect, kind of sus. Executable? Well, we have to have execute pages of memory, don't we?
Yeah.
Right? Like if I stop all executable pages of memory, we'd have a bit of a problem there.
If you can write, then execute.
Okay. We'll go over here to mem protection constants, and there's a bajillion of them. Do page read only. All right, doesn't this return what? Is it a far proc? I don't. Nope. LP void. Okay. I think next time I have to change out the VM image, I'm just going to give you this magic script somewhere in the VM. So it'll be in your path. All right, let's compile this bad boy. It works. If I run do exe, I get hello and I get goodbye. Okay, so read only, totally cool.
What? Uh,
Question?
yes. But what? Maybe this is me understanding Route Defender wrong. What if you're actually blocking the virtual alloc, but we don't get to see what, like, maybe the pointer was never allocated really, but the function went through and execution happened. We just, the thing that we expected virtual alloc to return was what we wanted to return.
Okay, so you're not wrong in saying, well, what if Rob Defender is changing this pointer, right?
Like always adding like a null pointer, something like that.
Yeah, I'm just going to subtract 8 from every pointer you get. Could I do that? Absolutely, right? I'm telling you right now, I'm not doing it. All right. Because that would be, in my opinion, like unreasonable for what we're trying to explore in the class, right? Now, if I were writing like some great troll thing, maybe Rob Defender grows over the next year, and it makes sense to have it in like the quarterly quiz as like some monster thing. Yeah, I'll give you pointers that are divided by 3, right? Like who cares? Everything is just going to be messed up. But then the challenge becomes reversing Rob Defender. I'm specifically telling you, like, I'm trying, I can't stress this enough, that the goal is not to like get lost in Rob Defender could do. The answer is yes, it could. The only thing I am doing in Rob Defender for this module is I am either blanket killing when you start something, or I am conditionally killing your process when a function is called given some parameter.
Will we know if it's a conditional stop or a straight stop, or is that something also we have to like infer from exit like while interacting with challenge?
I don't think it's super interesting. The original intent was for you to discover it, but I can tell you because like I don't think it's the end. If this number here is a 2, I'm filtering. If this number here is a 3, it's a kill.
What about the non-fold
Those don't do anything.
for now?
For now, yeah. Like they serve a purpose, but they don't serve a purpose for anything that is happening in this module. When I started like building this, I was forward looking, and so right now I have a reasonable amount of just like vestigial functionality that I know I need to tie in later, long term, but I'm not using at the moment, and that is why these can be trolls, right? Or this can be something that doesn't make sense. So when we can parse this as there's only 3 values that you need. And this will probably change in the future if you're watching this in the future. But right now, at time of recording, I am hooking virtual protect inside of kernel 32. I am filtering on something. I'm not telling you what that something is, but I'm also not like making it super sneaky, right? The idea here was that you could, what kind of allocations would be suspect? You guys already said, what if it is executable read write? Is there ever a case where we really need all of this? Like for most programs.
Okay.
So there is a case, and we talked about it in 466. When would you be writing the assembly as you're running before you execute? You even did a challenge that did this.
So I'm going to guess something in the current.
Nope.
No.
No, it was Yon 85. There was a JIT level. What is JIT?
Just in time. There's something.
Just-in-time compilation, right? So you write something in a higher level language, and you have to have some page of memory. And so you need to write the assembly that gets compiled to memory to then execute it, right? And now most JITs nowadays still don't use execute read write for their memory. Instead, they swap pages. And so you'll either have an executable page or a writable page, and then it gets re-protected. So they call virtual protect on it to go from writable to readable execute, right? And they swap these back and forth as they're going. because they're jitting that far ahead of themselves. But if you were like super performance conscious in your JIT, okay, maybe you need that. But I can tell you right now that in this Windows VM, there's nothing that needs this. Right? There's nothing that isn't whitelisted that's going to need this. So if we CL, what do I got here? Do.c. Okay. Live demo. What happened? All right. We get do.exe. We just get hello. We don't get the goodbye. Did I start this in practice mode, or am I a fool? I did start it in practice mode. Oh, I didn't. No. It is in practice mode. So I was going to use something I fixed today, but I didn't push to prod. I like CDB, right, as a term. So right now, WinDebug is whitelisted. CDB is not. So if I were to do this, what I wanted to do. Oh, nice. In the later ones that I was working on, it does get caught. Does get caught up by Prompt Defender, and it just kills it. It depends on what it's doing, because I am literally hooking every process that starts outside of a whitelist set here. Okay, so we should be at the beginning of it. We fire on. All right, we are at terminate process. If I hit K, I get my backtrace. Can I see what happened? Does this tell me anything? And this is what I mean when I say don't focus on the Prompt Defender exe. Don't go down that rabbit hole. Care about what's in your process.
I see.
Okay, so we see this. What is this? Great. Okay, I'm not sneaking stuff in here. I'm trying to make it so that you guys can see what's going on. Yeah, the way Prompt Defender works is it's injecting this DLL in every process that starts, and then I am hooking the functions that are specified in that rule, right? So that those functions get redirected into an implementation that is in hook DLL. So can I see what's going on here with GDB? Or it's not GDB, but I'm pretty comfortable with it. We're friends, like I am with GDB.
Can you check what's happening in that hook DLL?
Yeah.
Is the first?
Yeah. What do I need to do?
Just execute the program. See.
I executed the program. We're at terminate.
Oh, we're done.
No. So if we see here, I'm at NT terminate process. And then the debugger has been like, hey, you're about done, right? Or do you want to look at anything?
I would break it Rob into your one or add hook DLL.
But I can't break it hook DLL because it's a DLL.
Right.
In fact, right? Like if I look here, it's got no symbols and it's just a module that is happening here.
But we can. I don't know if this is what you have in mind, but we can break right before the virtual alloc and see where that goes.
Okay, so we could break right before the virtual alloc call and see where it goes. We could also recognize that this return address here is the return address into hook. I don't necessarily know what function it is, but I know that the call site where hook is going down this path of self-destruction is right here. And so I should be able to grab this return address, unassemble function, give it that. And so now I see the assembly of this function. And we were going to return to F40 right here. Here's the call where everything goes back. And what is it checking? They're like, this is a fail state. Yeah. This is a jump to, I'm going to guess, success. right? Because I don't want to fail. So jump to success. Jump to 2C.
That's the suddenly RCS.
Where is it?
The RCS, LEA RCS.
Okay, so that's a jump to fail. So I don't want this. What is this check? This is checking for 10. This is checking for 80. That is checking for 40. And that's a jump to fail, jump to fail. So I don't want this value to be 40. I don't want this value to be 10. I don't want this value to be 80. Right? All of
want it to be.
I do want it to be 80.
That's the success. Jumps to success.
F41.
Jump.
They're ending it. Testing.
F41 is beyond that call.
I know what the C code is because I wrote it. It shouldn't do that. But I agree with you looking at the assembly. Now, what we've done so far, just kind of reasoning about what's going on, is we have some idea of what the value is that is causing Rob Defender to, pitch a fit. We can see how this hook is implemented. None of these hook functions are meant to be extremely convoluted, right? They are about as straightforward as they can be, and they are mostly the same as far as like what is the logic. I'm checking for something. I either rabbit hole you to exit or I don't. So I'm not changing your pointers or making your strings become Unicode or anything crazy. Why would these numbers matter? Well, we said we have 10, we have 40, 30, fail. We have 10, we have 20, we have 40. Here's our 80, although I would expect 80 to be bad. Wait, what am I doing? Right? If you are mapping something that is executable, I'm saying no, you can't. All right. The goal is not for you to be hung up on, oh, what is Rob Defender do? It's here's my restriction, here's my constraint. How can I get around it? Hopefully that helps you kind of think about how do I sanity check, because I am hooking everything. So just make a simple program in C, right? 80 tested. And you can also see it in the debugger itself. So these are my requirements. What is something I can do? There's several ways you can get around this. Any thoughts?
I have a question.
Yeah.
So, so basically we inject a DLL into every program that we run. Right?
You are?
No, Rob Defender.
Rob Defender.
Yeah. So I don't know if we can do that, but can we unload a DLL from
Can you unload a DLL from a program?
the same way it has been injected?
Because
that's the only thing stopping us.
That's honestly something I didn't consider, and the answer is probably yes. If we're, then this is what I mean when I say like there's going to be these like rabbit holes that just like I've been going to curse it. As I think through it, so here's what would happen. I think we could try it. Here's what I think would happen. If you were to just unload the DLL itself, I can tell you that the DLL that I'm injecting does not clean up nicely. It may work, but what I think would happen is you would unload the DLL, it would not clean up nicely, which means the functions would still be hooked, which means they would jump to invalid memory. It wasn't intentional. I'm just like playing that out. It's a good thought, though. The intended solution is not to remove the DLL. So what am I hooking? Well, let's ask this. Do I have to virtual out to inject? Why or why not?
We call virtual alloc to have a piece of memory ready for us.
So there's lots of reasons why malware may want to allocate memory, right? Maybe you want to put shellcode there, right? That's why this is bad, generally speaking, very common type of thing to flag. Not necessarily as dumb as ROM Defender is. They might do some heuristic on it and be like, oh yeah, this makes sense. ROM Defender doesn't care, it just says that. But yeah, like this is very common in malware because they're going to try and map something that's writable, executable, put some shellcode, right? And then inject a thread, fire and go. Is there any other way that I could inject functionality into a program? I don't mind spoiling this one because I already did. You just don't know. So I don't record office hours. Do you remember what we did in office hours? What we talked about?
That's vague.
So we weren't calling. We were talking about the difference between like mapping shellcode and then pointing a new thread at it and firing versus doing DLL injection yourself. You want to unload a DLL.
How about you load?
Can I load a DLL? Yeah, I could.
But then how do you get execution starting into that loaded DLM?
Well, how do DLLs? Let's see. Do I happen to have that? Whatever. We will. I don't want to like just cat something since I'm on stream. We will call this my lib if I don't know what's in it. Making a DLL is not that hard. Now, normal programs do void main, and that's your entry point, right? DLLs have I believe it's DLL main. Boom. DLL main is your entry point for a DLL. What I really care about here is the reason for calling the function. So this DLL main, unlike main on a traditional executable, gets called once when we start. For a DLL, this can get called several times. And if we check the docs, we'll see that it gets called, for instance, when it's loaded or when it's unloaded. Remember when you said, well, why don't I unload it? Well, a well-written DLL would like do its setup stuff when it's loaded, right? And process attached. The process has loaded it. All right, cool. Let's do our setup work. Oh, you're going to unload me? Let me tear down whatever I've done, right? And so this DLL main gets called with a reason, and that is what determines how it gets started. So I could load a DLL in here, and then in my reason at start, say, hey, do whatever. Give me the flag. Would that work? Maybe. Depends how you do it. Am I calling virtual alloc? No. Should be fine. I'm not mapping anything. I'm not M protecting anything.
Just for everybody.
Yeah.
Hopefully.
I'm just loading a DLL. Okay. Now, you may need to inject a thread to load a DLL, right? There isn't just like you can map something into memory, right? You can do that. But that doesn't load the DLL. So you need to figure out where in memory something is. You guys have probably used this. I tried. You said this was broken on that last one.
Now it works.
Okay. I didn't see why that specifically was broken, but I did find a bug that might be why you say that and fix it. Get proc address, super useful function. You give it a handle to a module, you then give it the name of the function you want, it gives you the address. But this is giving it to you in your current process. Is that useful for what we're trying to do? I'm trying to load like my strategy here. Right, make this DLL yeet flag on load. Right, but I have to load it. How do I load it? All right, if we don't know, how do we consult the internet?
That's the end.
All right. All right, I didn't even type the right name. Load library A. What is this thing? Specify a path, and it's going to load the library. So there's a function that'll just load a DLL that you can call at runtime. Just one argument. Pretty easy, right? So if I can somehow make my calculator call this to a DLL that I create, I could make it load the DLL. Can I make my calculator call load library A? How? Okay. If you did the prior one, how did you execute something?
I allocated memory.
You allocated memory.
And then I wrote some shellcode to that memory.
I wrote some shell code.
And then I just also allocated a thread.
Wait. Did I allocate a thread?
Not allocate a thread, but like make a thread. Made a thread.
I did something with threads. I don't know, man. It was long ago. That's fair. So there is a handy function in the Win32 API called create remote thread. If I have a handle to a process, I can, and I have permissions, which I'm not doing anything to mess up your permissions here, to be clear. If it's wrong, it's because you did it wrong, not me. If I have a handle to a process, I can create a thread in that remote process. So in the alloc for what, one, your strategy was I'm going to virtual allocate some shellcode. I'm going to run my create a thread, fire it at my shellcode, it goes free. My problem that I have right now in alloc for what 2 here is I can't get executable shellcode. That's literally all I'm stopping you from doing, right? At face value. Do I need executable shellcode to call load library A? No. How can I call?
I could load the library because it only takes in the load.
So what does my thread have to do? Does my thread have to do a lot of work?
Just has to call load library.
It just has to call this function. Do I need shellcode to call this function? Okay.
I can't see how a thread will call load library without.
Well, what are the arguments to create remote thread? How did you get a thread to start at your random shellcode address, man?
2 weeks.
It's been 2 weeks. It all fell out. So what are the arguments here to create remote thread is the start address. Where are you setting this thread loose? You chose to set a thread loose at shellcode. Could we set this thread loose somewhere that makes sense to call load library? This is not a trick question. Where is load library?
In our process.
It's somewhere in the calculator. How do I know that?
It's because you loaded your library.
So I loaded my library, but we also know that load library A and for the first couple challenges, at least, these are all in kernel 32. As far as what module is it in, right? So somewhere, and we can see this in CDB. And if we list our modules, we see that there is a kernel 32. I can say examine kernel 32, and what I'm interested in is load library A. I don't know why I didn't like the first one, but we get some subs here for that. Okay? So could I just point a thread at this? What would happen?
It won't be executed with no arguments. It's wrong thing.
Okay, so I could point it here and it would execute, but you're saying it'd be no arguments. All right, we go back to our documents on create remote thread. I have a parameter argument here, so I can launch a thread at some memory address with executable instructions and specify the arguments thereof. Do I need shellcode? No. I can literally just spin off a thread, point it at load library, and then give it an argument. You agree? Okay. So it turns out I didn't need virtual alloc at all to do this. Was this an insane leap? If it is, that's cool. That means that it makes sense that this is due at the end of the semester because there's more intuitive leaps along the way here as far as what is the trick to get around this stuff. I'm going to show just the rules to kind of hit the point. I think it's how to open a file 2. It might be 3. I don't remember which one. Challenge RD rules. What's different here? There's one key difference. So I'm hooking things that open files instead of virtual, right? That's why it's how to open a file, right? But there's also no, yeah, that's because it turns out
it's kernel.
it's kernel base.
How does that make a difference? Oh, so if you load the library, that's what's going to get hooked. Even if the library calls create file A, it's going to call it from kernel base instead of the Win32 API.
So what is the Win30? So the Win32 API, we have to harken back to the lecture that nobody watches. That's okay though. That's why this module is awesome. Because people finally have a reason to think about this slide. I have some binary. This is my calculator. My calculator, when normally working, calls create file, which is linked to kernel 32. What does kernel 32's create file do? It calls kernel base, which calls ntdll. So, if I have my hooks, and I'm not saying that you have to do this, all right, but just thinking about this amazing diagram, I labored ridiculously over long ago. Now get to enjoy the fruits. If the hooks are on kernel 32, can you
Kernel base.
Yeah, you can find the thing that's in kernel base. You can just skip past it. The hooks are in kernel base. If the hooks are in kernel base, does that mean that you can call kernel 32?
No, it's going to go back to kernel base.
Right. Yeah, what I'm doing here over one of the things that's happening in how to create a file, a little series there, is I am moving the hooks further back and further back to where now you can't get to the other side of it, right? But if I'm hooked here in kernel base, you still have an escape hatch here with calling into ntdll. But we'll take our break now. It's like 100 degrees in here for Twitch Twitch's amusement. We'll take our break now, and I want to do a demo on how writing C code that touches NTDLL is going to be way different than writing C code that touches kernel 32 or kernel base. Because this is the intended point for programming, right? Is kernel base something that we're supposed to know about as like happy following the rules Windows cable? No. We have no guarantees about anything that goes on here. We definitely have no guarantees about what's going on in NTDLL, and there's no headers. Which means if I were to just try and call NT create file, you can't, because there's no
function.
there's a symbol, but what is it? There's no header. And I'll show what that means on the other side of the break here. So let's hide for a bit, somehow walk outside in Arizona and get cooler. And boom. All right. What did I do? Why? Yeah.
Did that catch us?
I don't know. I just saw that it wasn't my smiling face. If it is, I gotta fix it, which is unfortunate. It's a fantastic use of time. Okay. So, one of the things I was kind of alluding to as we were looking at the challenges here is that it's easy to call something in kernel 32 DLL, as I did. Oh, I restarted the challenge. In my, do I have a, dang it. In my do.c, right? If I want to call something, we can just include windows.h. We have our main, and I can just call create file A, right? I pass whatever the args are to it. And we just let the compiler figure it out, right? We run CL on my do.c or do.cpp. For the record, the compiler does care about suffixes. Suffixes matter on Windows, and it will complain to you about it. But the compiler will figure out where create file A is, right? Because there's header files for create file A. Now, if I want to try and call something that's in kernel base, the compiler is not going to just link this to me, right? So if I wanted to find the equivalent of create file in kernel base, let's see what we get. Do I have like a what.c, or I just need any, I don't even care what it is. All right. I have no idea what this is, but we're going to throw a debugger on it. I just want to have the modules here. So there is kernel base. Now we see this is all deferred. I don't think I showed you this trick, but it's a great useful trick. Dot reload /f. We're going to force the debugger to reload symbols. And then if we look, we have symbols. Why it doesn't do that when it starts? I mean, like the deferred makes sense. Like it's not going to load them if it doesn't need them until you try and get there. But right now, I just want them, so we can force reload it. So one of the things I might want to look at in kernel base is some create file, create app. Do I have a create file? I have here. I'm trying to create file too. Right. I can't write something that is going to call create file to just in my main function that's going to directly go to this location. The compiler won't do that. So how do I get there? How do I figure out where that location is? I could use GDB and like hard code this address, but remember, practice mode is a different boot than challenge mode. So any address you get, ASLR may suck, but it doesn't suck that much. So anything that you pull from practice mode will not help you there. We already talked about get proc address, right? Inside my do.c binary, is there a kernel base? Yes. So can I figure out dynamically where it is inside my own binary? Yes. We need to have a handle to the module. So we call get module handle, and it wants a name. Right? We kind of did this song and dance already, right? Notice that is a C string, not a CW string. As far as the Y versus not, it's the A versus the W. But you'll find that throughout as a problem. So I want kernel base.
So Is it not cap? Doesn't have.
So you'll find that most stuff in Windows is case insensitive, which is infuriating when you're jumping back and forth between the two, Windows and Linux. So I want to have a handle on kernel base. I then want to find, what was it? Create file 2. This is a void pointer, if I remember right. LP void. Why? Okay. This should compile. Good. We could, in fact, print this off. And we get an address. Hopefully that matches. If it's still hiding up here, what did I have? B1C00, B1C00, right? I'm looking at different processes, but we see that the function address is still the same. Now the question is, how do I call it? And this is where in assembly, it's super easy to just be like, we're going to call some register, we're going to call some address. We're just going to, boop, we're going to go there. How do I do that in C? I have a void pointer. Well, C is going to be very picky because remember, C needs to compile to a call that's going to set up all of the arguments of whatever it is we're doing. It's then going to call. It's going to have to convert our high-level language into assembly that calls a function. Now, I actually don't know, and I don't think it's in the MSDN documentation, to be honest, what the arguments are of create file 2 in kernel base. But I'm willing to bet that the kernel 32 version of it is literally just going to bring us there. I'm going to bet that the function signature of this is the same as the function signature of it.
That's an okay assumption to make.
So think about how it may not be true. Okay, so it may not be true in the literal C sense, right? But think about what the compiled assembly will do if I make that assumption. Like me defining this function signature this way, what am I doing?
You're setting up the registers.
Yeah, I'm just setting up the register, right? It might be wrong. I don't know. This isn't what I demoed. Like what I was going to hypothetically demo. I don't know what create file 2 is. We could take the debugger, go to kernel 32, create file 2, see if it manipulates anything, and prove that out. Does it shuffle anything in the registers before going off to kernel base? We could prove that out. I'm going to YOLO it. And then if it explodes, and we'll go from there. So what do I need? Well, I need to be able to cast this from an LP void to be a function pointer. And I need the function to be this type. So I'm going to say I have a handle that is a Win API named create file 2. I want this to be a function pointer. And the syntax of C, C++ for this is just crazy. And then what are the types that this function pointer is going to take? It's going to be this right. And I'm just ripping the documentation and I'm just making it up. Is this correct? I have no idea, right? Is this what a proper programmer should do? Probably not. Am I trying to write something? Oh man, I picked a bad thing. What is this? I hope that exists.
Why did you pick create file?
Because I wanted to do something different. It's more fun when it's spicy. All right. Yeah, you think I come up here for your benefit? All right. This is for my own amusement. Yeah. Do I journal? I do not journal. Okay. So I have that. And so now hopefully what I can do is I can say create file 2, and we're going to call this my magic putter is going to equal, we're just going to hard cast this pointer as a create file 2. Does everyone see what I'm trying to do here? The compiler might explode. All right. But the logic. This is literally just changing something that is a void star
So function pointer
to a function pointer that has these arguments. That's all I'm trying to do. Doesn't mean that it's correct, but it's the equivalent of saying, when I call this, I need to set up these registers. Right? That is what I'm trying to trick the compiler to do. Oh my gosh, I really didn't think that was going to work. So it accepted my syntax. I never did it. So I was able to cast this. So then how can I use it?
Can you use it like a normal function? Just my magic pointer that the arguments.
Okay. What are the arguments? I should probably read the documentation. LP file name. Okay. Is this, I'm in practice mode. I can cat the flag, right? So I want to open C flag. Desired access.
Think of open existing or generic.
Generic read is feeling pretty good. Now, obviously, as I said earlier with the memes, do not do this in your exploit. This will not work. You want to talk to the magic flag service that has a pipe. All right, so I want generic read. Do I want to share? Is sharing something I care about? Refer to the following table. 0 sounds like a valid number. Creation disposition. I want to open existing. P, this is an optional. Optional, baby.
Is it optional?
Oh, I know optional, in optional.
Like it might still need to be a pointer or it is nullified.
So I don't know this to be true. But in my experience, optional really means nullable, conditionally nullable. I didn't read all of the docs, so I may not be in a state where it's acceptable to be null. But that is what I found. I could, if you wanted to do this right, we can make one of these things.
Because I feel like if it tries to dereference that it's expecting a bunch of arguments, it goes to null, it might explode, right? Because it looks like it's a whole struct thing.
Yeah, it's a pointer to a struct thing.
Yeah.
Right? And so we can definitely make the struct thing, right? I would need a create file to magic parameter guy. And it's going to be this giant struct thing. And then instead of it being null, we give it the address of giant struct thing. Right? And that will type correctly, but now I have to care about what are the values of this. The size of the structure. Oh no, see, this is some dynamically sized thing. All right, see, this is why if it can be null, right? If it feels like it could be null, I think it's worth it to just make it null. Okay. What is the return value of create file to?
Oh, and
It's a handle. All right. I don't really care about the handle for this demo. What I care about is, did it succeed or not? If it succeeds, it's an open handle. If it fails, it's going to be this constant value, and we can get last here. So after we do this, I want to say if flag handle is this thing, we done goofed, error code, get last error. And then let's just return there. Now, I'm spending over a semester with me. I think you know which one's going to happen.
oh, well, the one.
So it compiled with a warning. It's saying incompatible types, char 8 LPC on line 13. Okay, how do I fix this?
Casting.
Okay, I could cast it. Where do I cast it to?
C string. What's it called?
So you're going to end up with a rabbit hole here. There's a difference between a W char, right, like a W char array, a W string, a Unicode literal, which this is not, a C string literal, and a C++ standard string. These are all very tightly related, but not 100% interchangeable types. What I have here right now is a classic Linux C string that you know and love that ends with a null byte. Every character is 1 byte and things make sense. If I want a Unicode, a long or a wide string literal, which is what this is asking for in our type, it's a large or long pointer to a constant wide string. Right? Like this is just a type def that Microsoft uses. That is synonymous with a Unicode literal. You can prefix with an L for long. This is now a Unicode, I guess UTF-16, if I remember right, literal string, and that should fix this. Look, no errors. Yeah, no errors, no warnings. It's a good day if this works.
We didn't even goof.
So we didn't even goof. What happened? Oh, I know what happened. I'm a silly goose.
You didn't save the.
What's that?
You didn't save the.
No. I just, so I wasn't thinking in this challenge. What challenge am I in? What is Rob Defender doing?
Oh.
Oh, you knew.
What is Rob Defender hooked on? I went all out of my way to call this directly, only for Rob Defender to be like, nah, bro, not happening. Okay. Well, we don't know that it works.
Well, we know that Rob Defender works.
Well, we don't, yeah, we actually don't know that either, right? Because Rob Defender if it does output anything in your thing that I'm hooked, it's a bug. It's not something I intend. It's just I write bad code. So if we actually have no indicator here that it was Rob Defender that killed us, I'm willing to bet that it was them. So I'm going to invoke some magic here, which you can do as well in practice mode. All right. So if you search services, you won't see this because if you type like get service, this service doesn't show up because it's a kernel service. That's the kernel module that is running under the hood that's hooking everything from Rob Defender. The other thing that I need to kill, and I don't necessarily need to, but for cleanliness sake, is the userland brain of Rob Defender because it's going to just freak out right now because nothing is as it should be. So we can take that. And now it's gone. So now Rob Defender shouldn't be doing anything. There should be no hooking there. I can do that because I'm in practice mode. And we're awesome, bro. First try. Okay. I think that counts. I mean, Rob Defender oversight. Get you thinking about it, right? So that's how we can get around the fact that this isn't something that the linker is going to hook us up to, right? We have to create the type and then pass the pointer.
Could we do the same thing for an NTDLL function?
The question is, can we do the exact same thing for an NTDLL function call? The answer is yes.
We just need to figure out how the parameters.
Right. So if I remember right, there is NT create file. It just has a lot more arguments, right? Well, we could take this and do the same thing to call directly into NTDL. We would have to figure out what is, this object attributes. How do I set this up? One of the things that you would see if I if you were to do this object attributes, one of the properties of the object attributes is the name of the object. And so by the time you get to NT create file, do you think that we're using a path that is C:// flag?
Probably do absolute or a complicated path.
The answer is no, because everything in the kernel is what? It's an object. It's in that giant object manager thing, right? Which means that the path, unfortunately, we don't open /flag, right, to actually solve these challenges. But we're going to end up with a path that is something like //?//C. You remember seeing something like this? It's probably like a month ago. Windows is forever. So way back, we talked a little bit about home, college, workspace, desktop, Windows. Boom, boom. Make this fit. I was messing around in PowerShell, right? I had like the create NT or get NT file, get NT object. We were looking at the ACLs, and everything was an object with an ACL attached to it. One of the things that we looked at was this global, right? Because internally, inside the kernel, everything is actually, not literally everything, but most things are some object that is managed by this internal object manager that includes files. Okay? And so when we reference something from the context of kernel, we are actually saying, I want to go to root, question mark is to get to this global folder. And this global folder is just a whole bunch of symbolic links to other tabs inside the object. But that's how we get full circle from why did I spend an hour talking about the kernel thinks everything's an object. It's because the closer you get to the kernel, moving from kernel 32, where we can lie to ourselves, right? Yeah, there's just a file structure, C, whatever. To kernel base, okay, it's still a file structure, but what's happening here between here and here is this is doing the lifting of turning that C/path into a kernel object representation to then get passed to NT create file that is the actual syscall in.
We can just attach a debugger and see it. When we go to ETDL.
Yeah. We can do that on this guy right here. So let's CDB on, oh no. I didn't do my magic dev enter.
Is it because cdb.exe gone?
Oh, yeah. Okay. So we want to find, what do I want to find? Let's go to, do I have kernel base? Yeah. List modules. What was the trick here to make this have symbols?
You know,
Just this?
slash.
There we go. We force it. Except we have to type correctly. Okay. I want to find the symbol in kernel base. What is this thing? Create. We did create file 2. So let's break at kernel base, create file 2. Let's go. I am there. Let's unassemble the function that is at rip. So we have a lot going on here. And where it should call into, it's going to go into create file internal. Let's trace until there's a call. So just find the next thing that gets called along this path instead of stepping through this like a noob. And we're apparently going to call running an app container. I'm going to step past that and trust that that is not where I want to go because create file internal sounds cooler. Right? That sounds like where I really want to go.
Just skip the NTDL.
I don't think I did. Did you? Do you know I did?
I don't know. I'm just listening.
Yeah, oh man, scare me like that. Okay, so now I'm inside create file internal. Do we see this thing? It's doing a whole lot of stuff.
Could we break at the create file in NTDL and see the
Wait.
trace?
We could do that. What I was hoping was that I could find where it's doing the transformation, but this is a rabbit hole of.
Well, we can see which thing got called for the transformation.
Yeah. Did I get it wrong? NTDL on ACID? So that exists. We can break there. Okay. When we look at our trace, it was somewhere in there, right? In that create file internal that called us here. And so inside, it's got to be inside this create file internal is where it's doing that mapping. Because by the time we are here, we've already done the transformation, right? So inside create file internal is where it is doing that remapping of the arguments from the Win32 API to the native API, the NTDL. If we wanted to step through it, we could see it, but it's going to be somewhere in all of this beautiful assembly. So probably right around there with the query information. But are you a believer that all of this is doing that? There's a lot going on. But that's how we get there. We could do the same thing that we did with kernel base. We call it into NTGL. We just have to be able to set up all of the arguments. The problem that we're going to run into, though, is with this. I only had to type def this pointer, right? Well, when I try and go into the NTDLL function, and it has where is it? See, you always end up with a bajillion friggin' tabs. You end up with like P object attributes, right? This may or may not exist in your space. And so you may end up having to type this struct depending upon what you're doing. So if you specify this and then this doesn't exist, the PIO status block doesn't exist. Okay, well, if you know what is this type, you create the type def for that for the compiler to understand what it is. In reality, it doesn't really matter other than the bytes are correct, right? The thing that we're fighting isn't Windows. What we're fighting at that point is the compiler. If I just lie and say everything is a char star and like go away, but I make the char star buffer be treated correctly, like it's the correct bytes, as if it were a P object attributes, it doesn't matter, right? Because the call is going to set up the arguments and then perform the call in assembly. The call E, so NT create file, it doesn't really know the type that was called. This is a compiler convention, not an assembly. So you will run into troubles there. Write some type defs, make it happen. It is in the documentation, right? Most of what you'll find is like this may be a P object attributes, which is going to be a pointer to an object attributes. There's probably documentation or the symbol object attributes exists, but P object attributes doesn't. Can we type def a P object attributes that is a pointer to a struct that's known? Yes. It's not going to be anything like super crazy, but just know that if that happens, it's expected. It's part of the pain of trying to call in the stuff that Microsoft didn't intend to. For a final thought here, what happens if I hook on NTDLL? What can you do?
Other than actually making the raw syscall myself, I don't know.
Okay. Other than making the raw syscall yourself, I don't know. And I would agree with that statement, right? It's kind of silly that Rock Defender starts off playing up here in kernel 32, because why would I do that when I know particularly malicious programs, right, will try and circumvent this? A reasonably sane hook is probably going to be at this layer. In which case, performing a syscall up in user land, you can do that. Now we're back to writing shellcode, right? Like it all kind of Ouroboroses itself, right? And you apply these tricks to kind of jump around, but there's something else we could do too. So if I want to call NTDLL, let's imagine a world where I don't have hooks, because the answer is going to be slightly different if Rock Defender is hooking things. But this general concept exists. What were we looking at? Create file? Create file 2. Let's unassemble the function ntdll create file 2. Let's reload.
Capital C.
You think?
Should be
It should be a capital F too.
Should be NT.
Oh, there we go.
Capital C.
You know what? I don't want to hear this. ntdll nt create star. Where is this thing? nt. Oh, it's not. It's nt create file without 2. I remember now. Okay. So, what is a call? If I call into this, is this part of this function very important?
Setting some stuff up. So I assume, yeah.
So I talked about this a month ago before it fell out of your head. RCX R10. We've seen this on Linux. These are different function calling semantics. If you're doing a syscall versus calling a function, right? Because RCX will get clobbered as part of the syscall mechanism, so that argument then gets moved to R10 instead. So that makes sense why that's happening. Why are we setting a value in the EAX? For the syscall, right? Could I do this myself? Yeah. Do I have to call directly into NT create file? I just showed you how to call into a raw pointer. Could I figure out what pointer I need to be right here? So I could put shellcode into userland that has a syscall instruction. I could do that. I think it's safe to say that that would be unusual behavior for a program. We shouldn't be doing syscalls outside of NTDLL. There's legitimately no reason for it on Windows, right? NTDLL is meant to be the wrapper of doing syscalls. So it's a reasonable thing that an EDR would assume is, if you're doing a syscall, is it in NTDLL? Like that is a sane check that I'm not going to say Rob Defender is doing right now, but that virtually any EDR worth its salt would want to do. Because you would never need to call a syscall outside of this. There's no justification. So maybe I need to call this syscall here. If I call NT create file, it's going to do this and then trigger a syscall. If I just need to trigger a syscall, can I set up my arguments and then call this as if it were a function?
Yeah.
And see. Yeah. I could just take this address, add whatever my offset is here, call this as if it were a function. It would work.
Well, aren't you looking that as you don't? Like,
So this is the statement is isn't Rob Defender hooking this? And some of the challenges, yeah. But this logic of somewhere, right? If I'm not hooked, it's very clear where I would want to be. Somewhere, if this thing normally behaves, it must be doing this. You agree? Somewhere in this virtual memory space, this needs to occur to perform a syscall.
so just dump it.
Can I just use the functionality that's already there? Yes. There's something to think about. Because writing a whole bunch of executable shellcode in virtual memory that you've mapped, and then just creating a thread that starts at it, it's a great place to start the module. I don't think that's a good place to end the module. Questions, comments, concerns? It's all beautiful, it all makes sense.
It all makes sense.
Okay. I don't have anything else then. I could ramble about COM, but I think it would be more coherent if we get there, if I record that outside of class. instead of YOLOing whatever demos I have that I didn't have time to look at. At least on stream. I'll do it off stream. All right, Twitch. It was a fine time, and I think everyone will be happy that we will be done with Windows. We're talking about Windows as of today, at least on Twitch. And we will go on to the exciting world of kernel exploitation to talk about something a little bit more close to home. With that, I'll leave you all. It's been a good time. Goodbye, good luck. Yeah.